Hi, my name's Jo Morgan. I'm a maths teacher, and today I want to talk to you about teaching pie charts. Now, this is part of a wider series of CPD sessions that I deliver called my Topics in Depth series. And the idea with the Topics in Depth series is that I think that teachers need to really spend some time, and I don't mean a huge amount of time, it might half an hour, 45 minutes, but just spend some time really exploring a topic in depth before they start planning any lessons on that topic. And it sounds so obvious, but actually it's something that we rarely have time to do. So let's say we're all teaching pie charts in a couple of weeks, then as a department we could sit down together, look at a CPD session like this and really make sure that all of us understand the real ins and outs of pie charts before we start planning any lessons on that topic. Because if we only have a very superficial understanding of a topic, then there's no way we can teach it in depth to our students. We can't give them a deep understanding of a topic if we don't have a deep understanding ourselves. So that's the idea behind this series of CPD sessions. I've specifically chosen pie charts to talk to you about today because it's a great topic, interesting history, interesting context, and has this fantastic link to proportion, which as we know is a real fundamental important topic in maths. So there's all sorts of interesting things we can talk about with pie charts. And I'm embarrassed to say that I've taught pie charts to my students many times and never even thought about any of this stuff. So now that I've prepared this CPD session, next time I teach pie charts, I'm going to teach it a lot better. Okay, so it's worth spending the time just so that we can improve our teaching. And if we do this for every topic, then it ends up where every single thing we teach, we have researched thoroughly enough to do a really great job of teaching it. There's a series of things that we should think about when we're planning to teach any topic, and this is what we're going to be looking at today for pie charts. For a start, we need to understand the background of the topic. What's the history? What's the subject knowledge? Is our subject knowledge strong enough that we can teach our students with a confidence that we really know this topic inside out? Then we need to look at curriculum. Where does this topic appear on the curriculum? If we're secondary teachers, do we know what they did in it at primary school? If we're primary teachers, do we know where this topic goes after our students leave and go off to secondary school? It's so important that we know the curriculum through and through. Also, how is this topic assessed? So what do typical exam questions look like in this topic? And where are the misconceptions when students answer those questions? So how do students cope with the pie chart questions that they meet in their exams? And what are we seeing that they're often getting wrong? Once we know what they're getting wrong, we can think about the pedagogy. So how are we teaching this topic, and is there a better way we can teach it to avoid the misconceptions that we end up seeing? And finally, resources. What are the really good tasks we can use to teach pie charts? What are the tasks that are going to help address misconceptions or to build that deep understanding that we want? So all of these things we should look at for all topics that we teach, and today we're looking at them for pie charts. So let's start by looking at a bit of the background and the history. Right, much of the maths that we teach is ancient. If I look in textbooks from the 1700s, the 1800s, or even further back than that, I'm seeing arithmetic, algebra, and geometry. So we have these three key strands of maths that have been taught forever and have been around since antiquity. So these are not new things in maths at all. Statistics, which is taught as part of maths, although some would argue that it should be taught separately. But statistics is the new entrant to the curriculum. So statistics is relatively new in terms of the sort of concepts and the ideas, but also only really in the 20th century did we start teaching it in schools. And now we know how vitally important it is to teach statistics, because we know that statistical literacy is absolutely key to modern living, because otherwise we can be tricked by statistics all the time if we have no idea what we're looking at. So we know it's really important, but we know it's actually relatively new compared to the rest of the maths that we teach. The first ever pie chart was contained in a piece of work by William Playfair, who, I don't know about you, but I hadn't heard of William Playfair. He's not particularly famous for having invented the pie chart. But that pie chart, and it's depicted there on the slide, it's a pie chart to do with the Turkish Empire, and that was the first time a pie chart has been seen in history. Now, it's not like he put this in a piece of work and then suddenly everyone around the world was drawing pie charts. It took a little while before these became a bit more mainstream or used commonly in statistical works. And it was partly Florence Nightingale who popularised the use of pie charts. Now, you probably already know about Florence Nightingale and her contribution to statistics. As a nurse working in the Crimean War, she produced all sorts of analyses and in which she used data representations that hadn't been used before. And in fact, she is often credited as being the person who popularized statistics in the early days and popularized data representations. So in other words, graphs to show information clearly and to convey messages. So Florence Nightingale really gets the credit for a lot of these things. She wasn't necessarily the inventor of pie charts. That is credited with William Playfair. Unfortunately, not everyone is a fan of pie charts like Playfair was, though. Have a look at this quote. "There is no data that can be displayed in a pie chart that cannot be displayed better in some other type of chart." So, you know, not everyone likes pie charts, and in fact, I'm not a fan of pie charts myself. I understand Playfair's original idea. I get what he was trying to get at, but pie charts can be pretty useless. Now, this quote is by John Tukey, and John Tukey was a very famous statistician, very much a leading expert in representations of data. He lived in the 1900s, died in the year 2000. And it was responsible, for example, for the invention of the stem and leaf chart and stuff like that. So he has invented representations that we now use, and if he said something about a representation, then you listen to it because he really knew what he was talking about. And he's saying that pie charts are rubbish. He's saying don't use them. He's saying there is no data you can display in a pie chart that you can't find a better chart for. And we'll look at some examples of bad pie charts and good pie charts. But just in terms of our teaching, I think it's really important that we don't pretend that pie charts are a great way of displaying data. They are often very flawed. And even though our job perhaps is to just teach students how to draw a pie chart, I think it's really important that we convey the pros and cons of pie charts too. I think that's just part of our duty as teachers to make sure students know that we are not endorsing them as a good way to present data. Now, charts should be a way to take information to make it more understandable. Like, that is the whole purpose of a data visualization. If we're not doing that, we might as well just present raw data to people. Okay, there is no point in presenting charts if it doesn't make that information easier to digest. Now, this is an example from Ed Southall's book, Yes, But Why? Which is a book about teaching for understanding in maths, and he gives this as an example of an absolutely useless pie chart, and I'm sure you'll agree. I mean, take a look at that. Goals scored by all Premier League teams 2015 to 16. It doesn't tell us anything. You know, if we look at it really carefully, maybe we can try and get an idea of which team scored the most goals and which team scored the fewest, but not really. I mean, this is awful. In Ed's book, he says, don't be shy about pointing out the flaws of pie charts. It will make lessons on the topic more interesting, and students deserve to understand the advantages and disadvantages of each method of data representation. Statistics is one of the few topics in mathematics that students will be exposed to throughout their life beyond schooling, so a critical eye is no bad thing. Now, they're very wise words from Ed. Just as I was saying a minute ago, we need to make sure that we are not pretending that there's nothing wrong with these data representations that appear on our curriculum. It's interesting for students to say, what a rubbish chart, and for students to know when is it appropriate to use a pie chart and when should they not be choosing it as their data representation. Now have a look at this. Which of these is the biggest sector? So this is a pie chart representing some data, and you can see straight away it's rubbish. It's rubbish because I don't know which one the biggest. I think maybe it's E there, but I can't really tell the other sections which one's the biggest. I mean, I just can't tell. If the sections are all a similar size, then a pie chart is just a total waste of time. If you have a look at this, these three pie charts, the equivalent bar charts have been drawn underneath them. And I think we can all see straight away the bar charts are just far more clear and revealing about what the data is showing. If you have a look at the first one, I can't tell necessarily that the section A is the smallest, then B, then C, then D, then E. I can't tell that by just glancing at the pie chart, but I can tell it by glancing at the bar chart. So you can see that there are times when pie charts just don't make any sense, and a bar chart tells us a lot more. And so one of the reasons that we should not use pie charts, or one of the scenarios, is when the sections on the pie chart are all a really similar size. an angled 3D pie chart is an excellent way to lie to you. That's a quote I took from an article on everything that's wrong about pie charts. And the only reason I think people ever do angled pie charts is because Excel lets them do it. It's not actually a good choice in any circumstance. Have a look at this. This is the same graph shown in 2D and 3D. And you can see that in that 3D pie chart, it really seems like that red section is the biggest. But if you look at the 2D pie chart, you can see that it's not. So that's an appalling use of misrepresentation. 3D pie charts should never exist, and no one should ever be making them. They are totally misleading. It's not to say that pie charts are always useless. The one single thing a pie chart is good at is when you're comparing 2 to 3 different data points and they have very different amounts of information. So if we look at this pie chart, I can see that blue is a lot more than red, and that's it. If I have too many sections, it's useless. If all the sections are the same size, it's useless. But if I have 2 or 3 quantities with very different magnitudes, then perhaps a pie chart is not awful. Now, I've taught pie charts a number of times, and I actually didn't know there were certain conventions for how best to draw them. In the book Developing Thinking in Statistics, Alan Graham sets out some of the key rules that we should follow when drawing pie charts to optimise their usefulness. I don't know why I didn't know these things. I've taught pie charts, and I've literally never told my students that there are certain things we're meant to do when we draw them. So, for example, the first slice of pie should be drawn from 12 o'clock. I didn't even know that. Then we're meant to arrange the slices clockwise, and if there is no particular order they have to be in, then we should order from the biggest slice first. And just to give you an example, there's an example of a pie chart that's not been ordered in that way, and there's an example of a pie chart that has been ordered in that way, and the pie chart on the right is easier to read, it's more pleasing to the eye than the pie chart on the left. And these are just conventions that are widely followed in those who take an interest in data visualization, and it's not stuff that I ever even considered before. So I didn't know you had to start at 12. I didn't know you had to order with the biggest slices first. We should only use pie charts if there aren't too many subdivisions. I've already mentioned that, and as long as none of the subdivisions are too small. So, if we have really a maximum of 3, I mean, maybe up to 5, but definitely no more than 5. If we have more than 5 subdivisions, we should not be using a pie chart. Also, pie charts don't make sense as ways of comparing data. Side-by-side bar charts, stacked bar charts, for example, make much more sense. But using 2 pie charts side by side for comparison is just nonsense. And it's a shame that so many exam questions do include side-by-side pie charts. It's a really awful way. If it takes a lot of mathematical analysis to understand 2 pie charts side by side, and if it takes kind of a level of education rather than a level of intuition, then it's a bad thing to do. Okay, it should be more intuitive understanding data. It shouldn't require someone to sit and work something out when they look at the graphs. So side-by-side pie charts are just a rubbish idea. So let's have a look at what's on the curriculum for pie charts and look at how it's assessed and what the common misconceptions are for this topic. So pie charts first come up on the curriculum in year 6. And it says on the curriculum that people should be taught how to interpret and construct pie charts. So they're not only learning to read them, but they're learning how to draw them as well. In the notes, it says that pupils need to connect their work on angles, fractions and percentages to interpret pie charts. So there's actually quite a lot of concepts that come together in this topic. So let's have a look at 3 examples of SATs questions. So this is year 6, end of primary school questions on pie charts, because I love these questions. These are fantastic questions, all to do with proportional reasoning. Have a look at this example. It's all the way back in 2005. This is very much an old SATs question. But I love the way the pie chart has those little partitions drawn on it. So you can see the 8 little sections, which means that we know that we could split it into 8ths, and that tells us everything we need to know. It says we have 32 children took the survey. So that means that each sort of subsection, if we use those little partitions they've drawn, represents 4 children. Once we've worked that bit out, just using a bit of standard proportional reasoning, then all these questions are then really straightforward. 10 children like chips the best. Well, no, because it's two of those little subsections in chips, and we know each subsection is 4. So this is, once we've worked that out based on the fact that we have those subsections, there are 8ths here. We can see the 8ths have been drawn. 32 split into 8ths is 4 per subsection. The whole question is really just a case of reasoning, and it's a really nice example of a reasoning question. This is a question I like less. This is from 2000, so this is a really old question, but I don't really like this question quite as much. We have 2 pie charts side by side that represent totally different quantities. So we have Tony found 80 creatures, and we have Gemma found 36 creatures, and they're both presented as a pie chart. And we know that comparative pie charts side by side is not a great way of displaying data. It would be better displayed, for example, in a bar chart. It says estimate the number of worms that Tony found, and we can see that's slightly more than a quarter. So we're going for slightly more than a quarter of 80. So I quite like that. But then it says who found more snails, Tony or Gemma, and then explain how you know. So there again, we're having to work out how many snails Tony found, how many snails Gemma found. But what I do like about it is there's no angles. This is totally done by the fact that the snails there is a quarter, and the Tony's chart and the snails is a half on Gemma's chart. So no angles at all involved in this SATs question. Another example here, this is more recent, this is from 2018, but this time we do have an angle mark, but just one angle. So again, this is not a question which becomes all about protractors and fiddly angles and all these sort of extra challenges of trying to think of more than one thing at a time. This is a proportional reasoning question. It's really nice presentation of a question on pie charts. We have 20 big cats in a zoo, and we have to just say true or false for the statements at the bottom. There are more cheetahs than jaguars. Yes, we can see that, because if we have a basic understanding of pie charts, we can see that the sector for cheetahs is larger. The total number of lions and tigers is 10. Well, no way, because lions and tigers are more than half, and we have 20 cats here in total. This is, to me, accessible to students, helps us to see whether they have a good understanding of proportions, and is really just a nice reasoning question. So I really like the way that these questions are presented in SATs papers. Now at Key Stage 3, so in years 7, 8 and 9, we have the same content as primary school. Construct and interpret pie charts, and that's all we're given there. So it's exactly the same wording as before. Now this is the only mention on the whole secondary curriculum of pie charts. In other words, it's not specifically mentioned at Key Stage 4. So when we get to Key Stage 4, there's nothing new to teach. Pie charts have already been taught at Key Stage 3, and at Key Stage 4 we revisit and we extend that topic. It often gets assessed at GCSE, so let's have a look at what those GCSE questions tend to look like. So when I researched this by looking through lots of exam papers, I was quite surprised to find that it comes up loads on foundation tier, so something that we're asking of our weakest students, but quite rarely on the higher tier, even though I think that pie charts is a really challenging topic. So it is mostly examined on foundation tier, and unfortunately our students at foundation tier just don't do very well on it, which I'm not massively surprised by, given the challenge involved, the need for strong proportional reasoning skills, and the need for problem solving skills. If you have a look at this question, which is quite typical, we have this split between men and women. The men's section is labelled with an angle, which means that students can work out what the angle for the women's section is pretty easily. They need to know one angle fact for that. They need to do 360, take away 110, and they'll have that angle. And that is the easy mark in this question. Okay. Then it says that 3,360 more women voted than men, and we have to work out the total number of voters. Now that's something that students might do with a bar model, or perhaps some other proportional reasoning technique that they're familiar with. But before they can even do that, they need to understand that really tricky bit of the question, which is not that the section for women represents 3,360, but the bit that's more for women than men. So basically, once you've got that angle for women, if you take away the 110 degrees from that, it's the remaining bit that represents 3,360. Now, unsurprisingly, students really struggled with this question. Most women worked out that angle fine, and that's great, but that's not testing knowledge of pie charts in the slightest. That is just testing a simple angle fact. And most students couldn't progress any further than that. As you'd expect, a lot of students who did progress further took that 3,360 as being the total for women and not the bit that's more than men. This is a really challenging question, so not surprising at all that students struggle with it. This again is a foundation question from 2019. Now this one is literally draw a pie chart. Here's the data, draw the pie chart. And there are so many challenges in drawing pie charts. It's the first of all, you've got to understand the size, how you work out the size of each angle. But then there's the actual bit with the protractor, which students are not well practiced in and students find very challenging. I recently had some students drawing bearings with a protractor, and it's like they couldn't get their head around the fact that they could turn the protractor. They didn't have to have it on a horizontal angle. So like even like the very things that we take for granted, the fact that the protractor can be turned is something that our students need to be explicitly taught and they need to practice. So there's an awful lot going on in a draw a pie chart question. The marks here. Now, given it was 180 scoops of ice cream, we want students to realise that basically if they double all of those numbers of scoops, they get 360 and then they've got their angles. But I just don't think it's as straightforward as that. It may seem obvious to us, but I don't think that's as obvious as we think it is. So they get 1 mark for kind of working that out, that whole thing about 2 scoops per degree, no, 2 degrees per scoop. But if they get their angles right, then it's implied, that mark, so they don't have to specifically write that down. Then they work out their angles, 90 degrees, 150 degrees, 100 degrees, 20 degrees, and again they're getting a mark there. Then they get a mark for drawing the pie chart, so that's basically knowing how to use a protractor but also using it accurately. And then the final mark is for everything being correct but also labelling the sections. So unfortunately it wasn't very well done, and I'm not actually surprised given how much there is here. In a foundation paper, this is an awful lot of stuff to do in one question. Majority of students correctly completed the sector angles. The ones who correctly completed the sector angles also labelled the sectors. So if they got the pie chart right, then most of them got 4 marks. But there were many pie charts drawn without any calculations, so students are just randomly drawing lines on this thing. And many didn't connect the scoops 180 to 360 to get the 1 scoop is 2 degrees. So a common error here was to complete only half the pie chart. So some students drew an angle of 45, an angle of 75, an angle of 50, and an angle of 10, and left it at that. And now that is just like, what? That just shows like a total lack of understanding of pie charts. But yeah, I think that this is challenging stuff for foundation level. Here again, we have a question from a foundation paper, because these questions tend to be on foundation level. And again, it's one that our students have really struggled with. Students do not do well in pie charts at foundation level. And arguably that's because it's a really complex topic that brings in lots and lots of different mathematical ideas. In this question, we have a half-drawn pie chart, and students are asked to finish it off. They're told that there are 4 candidates in the election, J, K, L and M. We've drawn on the sections for J and K, and we're told that twice as many people voted for L as for M. Now, most students have no problem working out the angle here, because it's 360 subtract the 90 and the 72, and that's nothing to do with pie charts. That is an angle fact question. It's a basic angle fact that is 360 degrees around a point. So most students can do that, and the fact that they can do that tells us nothing about their understanding of pie charts. The next part of the question is asking them to split it into a ratio of 2 to 1, and that's where they're going wrong here, because what they're doing is working out that angle and splitting it in half and giving the same amount to L as to M. So actually there's quite a the fact they can't do that bit shows they don't understand the proportionality aspect of this question. And if they can just do 360, take away those 2 angles, that's just telling us that they know a basic angle fact. So lots of students struggling to split that effectively, split that into a ratio of 2 to 1, that remaining section there. Part B says that 16,200 people voted altogether, and how many voted for J? Now I see that as a fraction question. I see that as 72 out of 360 voted for J. So what's the same fraction of 16,200? Students really struggle with that. Let's have a look at the examiner feedback. So they're saying that part A was reasonably well answered. although I think perhaps that was just students getting marks for working out that basic angle bit. It says a common error after successfully working out 198 was to divide the section into 2 rather than 3. And then it said that a significant number of students were unable to measure accurately. So even if they managed to correctly work out what the angle should be, a lot of students just can't use a protractor well. And then it says part B was really badly answered, which surprises me because actually to me part B is the more kind of standard pie chart procedure. So it says that some students worked out that there were 45 voters for every 1 degree, but a lot of students found 72% of 16,200. And there's nothing, there's no percent, this is not a percentage question. So, or some of them divided 16,200 by 72. They're literally just seeing 2 numbers and just doing something with them with no understanding. Another question from foundation level AQA, and this is a really recent question, November 2020, is really, you can see that AQA really like this idea of kind of bringing ratio into pie chart questions. So here we are again being asked to complete the pie chart, and we're being told the number who answered red is 3 times those who answered green. So it's really similar to those other questions. And then we have, there are 600 altogether, how many answered white. So that is so similar to that last question. AQA are asking the same stuff again, knowing that teachers will have read the examiner report from the last session and hopefully would have improved these skills with their students. And obviously this one I don't have examiner's report for yet, but I'm going to guess that the performance was probably not much better. Now, it doesn't, pie charts don't just come up on foundation. This is Edexcel, where we see pie charts on the higher tier. This is a really tricky pie charts question because it involves interpreting a histogram and then using that histogram to find the size of an angle in an equivalent pie chart. Now, this is a whole other level of difficulty. This was quite near the end of the paper, so definitely considered to be a challenging question. Histograms tend to be considered to be quite a challenging topic, but this is a whole other level of pie chart challenge. Now, Edexcel also commonly features pie charts on their foundation tier, just like AQA does. And a typical example is one like this, where first they're being asked to draw a pie chart, they're given the frequencies, they're given a blank pie chart, they're asked to complete it. And then we have a pie chart comparison here, where we have the pie chart the students have drawn and a pie chart to compare it to. Here's another pie chart question. It's actually quite interesting to have a look at the analysis on this one. So students, again, foundation tier, being asked to draw a pie chart, just given the frequencies. So this is kind of the whole procedure from scratch. Here's the information, make it into a pie chart. Now they're saying that most students had a go at this, and a lot of them realised, this is the great bit, a lot of them realised that the total number of fans was 36. So if we multiply all of our frequencies by 10, we turn them straight into angles that will fit around a 360-degree pie chart. So that's fantastic. That is exactly the reasoning we want our students to notice. So that means we want an angle of 110, 170 and 80. These are really simple angles to deal with. Says that many students were then able to transfer the information to the pie chart with the angles drawn. However, it does say that some students again struggle to use a protractor. Our students really find protractors difficult, and we know that. For example, instead of measuring 110, they measured 70, which shows they're using the wrong scale on their protractor. It's interesting, it says at the end there, it was also evident that not all students use a ruler. I mean, imagine losing a mark for not using a ruler. So, there's all sorts of problems here, but it seems to me that the main one is not knowing how to actually draw the angles properly, even if they can work out the angles, and this was an example of the simplest possible numbers to work out. So that's how it looks in exams. So you can see it comes up a lot on foundation tier. Students are often asked to draw pie charts either from scratch or using a partially completed one. Students are sometimes asked to interpret pie charts by working out numbers or fractions, but it seems to be that one of the main problems is how to work out the angles we need and then use a protractor to actually draw those angles. So that seems like something that we need to find a better way to teach. Now, the process of drawing a pie chart from scratch is massive amounts of cognitive overload in this topic. I mean, it's something that if you're going to say, right, today I'm doing a lesson on drawing pie charts, you can't expect to cover all the skills in one lesson because it's massive amounts of overload. Just think about the skills involved in drawing a pie chart. So first of all, you've got to work out the angles, and that's actually probably the challenging bit. That's the bit that requires the proportional reasoning. Then you've actually got to perhaps draw a circle. That depends on whether you give the students pre-drawn circles, which I really recommend because drawing a circle is not as easy as it sounds sometimes. Measuring angles, that's something we know students struggle with. Even like knowing how to orient their protractor on the page is something that they find difficult. Using a ruler, something that some students still struggle with, even at GCSE age. Labelling the sections and just remembering they have to do that. And then, of course, there's probably some element of problem solving that comes in the same question. Once you've drawn your pie chart, you don't get left alone. You then get asked to do something with it. So there's so much going on in a single question. And so if we atomise these skills required, it's huge, it's complex, there's loads of them. You know, we might be trying to teach students how to draw pie charts when they are not competent in measuring angles. We might be teaching students how to draw pie charts when they can't even use a ruler well. And there's so much going on here, so we have to find a way to minimise the overload in order to teach this effectively. Now there's some really great tools available, and this is a tool from MathsPad, and you can see how much is going on. So just look at this process. The students are being asked to draw a pie chart. We're using the MathsPad tool to draw the pie chart, but it really shows just how many steps there are. I mean, look at what's going on here. Look how long the procedure is to draw a pie chart. So if we start from the beginning, first of all, you've got to work out the angles. Then we need to put the protractor down, draw the lines in the right place, label the section, and then keep doing that for each of the different sections on the pie chart. And it is a long process with a lot going on. So there are some really easy wins to start. So we don't want students drawing circles with a pair of compasses in a lesson on pie charts, because even that is something they may struggle with, and we don't want that to be the focus at all. So providing, for example, pre-drawn circles with a line in to show that you start at 12 o'clock is a really good starting point, and these are available from MathsBot, for example. You can just download a page of pie chart templates. So that's a good start. So when we're teaching students how to construct a pie chart, we do have a big decision to make in terms of what method we are going to teach our students. Now, there's a whole load of different methods for working out angles, and they're all equivalent, of course, because methods in maths are all equivalent. They're just different approaches or different procedures to get to the same solution. So there are a number of ways of working out the angles, and let me just talk you through the sort of options here. So this example, and this is a screenshot taken from MathsPad, is what I call the fractional approach. So here we say, if I want to draw a pie chart for this set of data, and I've got 54 animals here, so I say, well, cats are 18 out of 54 is the fraction they represent of the total. So we want the same fraction of the total number of degrees. So in other words, 18 54ths of our animals are cats, then I want 18 54ths of the circle to represent cats. So we form that fraction and we multiply it by 360, and that gives us the angle. So that's a kind of fractional reasoning approach, and that's a really, really common way of doing this. This is a similar thing. Again, I just found this on Google Images. This is just a typical example of how it's taught, but actually using a specific formula, which is the same formula there, but just wasn't specified before. So the formula is frequency over total frequency times 360. So for example, in this one, we have favourite colours, and we say, well, blue is 6 is the frequency, the total frequency is 40, so it's 6 out of 40 times 360. So it's a fractional reasoning approach, and you can attach a formula to it, or it can be done intuitively, but either way, this is a pretty common way of working out angles in pie charts. In fact, this is a way that I've seen in books that I've read that are now quite old. So this is a book from the 60s that says to find the size of an angle, we need to work out the fraction p over n. So p is the particular quantity and n is the total, and then we multiply it by 360. So there's certainly nothing new in this approach. It's been around a long time. And there's another example from a book, again from decades ago, where it says that we work out the fraction over the total and multiply it by 360. So really, really common way of doing it. But it's not the only way of doing it. And although the other methods are equivalent, they do look a bit different. So if we look at this one, we've got 18 people's favourite colour. and we do 360 divided by 18. Now think about what that's showing us. That's showing us that for each person, how many degrees do we represent on the pie chart, and we're finding it's 20 degrees. So every one person is represented by 20 degrees. So if I have 3 people, I need 60 degrees because one person is 20 degrees. If I have 4 people, I need 80 degrees. It's equivalent, but it is a different way of teaching it. It's a different method. So here we're saying always do 360 divided by total frequency and then multiply by that by each individual frequency. I can see a similar method here. Again, this is a book from the 70s, and it says a farmer divides his land into 3 parts. He uses 5 acres for corn, 3 acres for carrots and 2 acres for pigs, and it's telling us to add all the acres together to get 10. That's our total frequency. We know that 10 acres is 360 degrees, so 1 acre must be 36 degrees, and then we can work them all out. That to me is a little bit more proportional reasoning than the kind of fractional approach, but they are of course equivalent. Using that nice idea of proportional reasoning kind of ties in with ratio tables, and many students would have been taught ratio tables when they've learnt about proportion, and they need to know that it works really well here to use the same approach. Whatever approach students have been taught when answering proportion questions works fine here. So for example, here we have a GCSE question, we've talked about this one already, where we have a total of 36. So we know 36 fans is the total, and that represents 360 degrees, which is our pie chart total. So if we divide both of those quantities by 36, we find that 1 fan represents 10 degrees. And then we can multiply both of those quantities by 11 to find that 11 fans represents 110 degrees. Now, if you've taught your student this kind of ratio table layout for proportion questions, then you can keep using it here. Okay, we don't necessarily need the formula, frequency over total frequency times 360. We don't need to use a formula if our students have a solid understanding of these kind of approaches like ratio tables. I spotted this in John Stewart CPD session. I thought this is really interesting because what he's done here is he's taken his boxes format, and many of you will be familiar with John Stewart's boxes format, which is a really great way of teaching proportion. And he said divide 360 in the ratio 7 to 4 to 9. So we have 7, 4 and 9, the total is 20. We want to divide 360. And then we say, well, if 360 represents 20, what do we multiply 20 by to get 360? And we multiply all the others by it. So it's a proportional reasoning, but actually this doesn't look like a pie chart question. But actually what we're doing here is we're answering a pie chart question. And the pie chart question would be something like this. 7 people walk to school, 4 people cycle to school, and 9 people get the bus to school. Draw a pie chart. So what we want our students to see really clearly is the equivalence between a pie chart question and a ratio and proportion question that they already have a strong technique for answering. And it's making that equivalence and making them see that this is essentially the same thing, just presented in a different way, that will really help them to be able to work out these angles effectively. Whether they can actually draw the angles is a totally separate issue, so we can deal with that separately in practicing how to draw angles and all the misconceptions associated with that. But working out the angles, we need them to see this is proportion and they have done proportion before. Now, one technique that I really liked that I saw in an old textbook was one where really we start just with fractions and we don't go anywhere near angles. So have a look at this. It says, here is a pie. Alan gets half the pie, Matt and Jane get a quarter each. Draw the lines and label them. Now that's really simple. There's no angles here. We're not having to work out angles at all. We are doing this based on fractions. That's a really nice starting point for pie charts. The next bit of where that leads to is, say, more complicated fractions, but still no angles. So here we have, here's a pie chart. What fraction of the day is spent on lessons? And we can work that out because we can work out what the sections represent and how many sections are there. What fraction of the day is spent on meals and breaks? And if the school day lasts 6 hours, how many minutes are taken up with meals and breaks? Now, we're not going anywhere near angles here, but we're developing an understanding of what pie charts are. So this seems to me to be the absolute sensible starting point in primary school and going through into secondary, is avoiding angles altogether in the initial stages of teaching pie charts. So all we're going to do is start with drawing and reading pie charts with fractional divisions. And then only once we've got a real strong understanding of that and the proportions and how pie charts make sense, only then moving on to pie charts that have angles marked on them. And only at the very end are we going to go anywhere near protractors where students are having to draw their own angles, because we know that in itself is a difficulty. So these are the sorts of questions I mean at the very early stages of understanding, developing a really strong conceptual understanding of pie charts. So here we have the pie chart shows proportions of different coloured sweets of a tube of Smarties. What fraction are red? Oh, I can see a quarter are red. What fraction are blue? Well, I need to work out that that is an eighth of blue. So you can see that there's a whole load of reasoning, proportional reasoning, and fractional work we can do before we go near angles. And this isn't anything revolutionary. I mean, these questions have existed forever. I mean, this is a 10 ticks worksheet. So this is stuff that's been around forever. But it's an idea of start with this. Don't go near angles. Start with fractions. Develop that understanding. You can do a whole load of great questions that involve circles that have been split up into fractions. And you're you're developing that understanding of pie charts with students before you say, right, let's just draw a pie chart from scratch and work out the angles. In fact, you see it here in this lesson from Boss Maths. Here we've got the pie chart showing proportions of people choosing dessert. There are 140 people, but look at the angles that have been used. Really, this isn't an angle question, this is a fraction question. We can see it's a half, a quarter and a quarter, and that makes this question a lot more accessible, and that means that our students can access a proportional reasoning without having to worry about complicated angles. And here's another one where we have angles of 180, 90, 45 and 45. So how many 4 students walk to school? So we can see that 45 degrees represents 4 students. So how many travel by car? Well, it's double. We don't need to do any measuring. We don't need protractors out. It's double the amount of students went by car. So that is 8 students. How many took the bus? Well, it's double the amount that went by car. What fraction walked to school? Well, we can work out the fraction if we understand that it's half of a quarter, which is an eighth. How many are in the class altogether? Now, that's a great set of questions, all to do with reasoning, and you know, just such a sensible starting point for pie charts. And only then, once we've really developed that understanding, should we be going near questions like this. Again from Boss Maths. So this is a question where we now have angles involved, and now instead of saying, well, 90 is a quarter, we're saying, well, 100 is 100 over 360, and we can go from there. So it's that idea of developing into angles, but only once we've got that strong understanding with fractions. Once you are looking at angles, a really good resource to look at is this example from variationtheory.com, produced by Jess Pryor. And the thing that's really nice about this is the clever choice of numbers really makes you think, or is designed to make you think about what the pie chart will look like. If you look at this, the first one has 4 people going by car, 5 walking and 9 going by bus. And the second one has the same proportions but doubled. But because proportionally they haven't changed, the frequencies are doubled but the proportions haven't changed, it means that pie chart will look exactly the same. And that is what gives students pause to stop and say, well, that's weird, I got the same pie chart even though the numbers were different, because that will make them think what's going on with a pie chart. The third question has the walk category in the previous one of 10, it's been split into a 6 and a 4, but otherwise the pie chart stays the same. Now each stage here is designed to make students stop and think, oh, why did that happen? And that thinking is what gives them that greater understanding of what's going on in pie charts. I mean, there's a fantastic choice of questions here, and they really do, once the students start drawing these, or at least not even drawing the pie charts, but just working out the angles, really should make them stop and think, well, what's going on there? Why has that changed? Why hasn't that changed? Here's a lovely task from Don Stewart. Again, lots of thinking to be done here, lots of reflection, lots of reasoning. So here we have a set of tables and then a set of bar charts, and students have to figure out which goes with which. And then we have the same for pie charts. Now I find this really interesting because I look at that and I think, well, Q has this one massive chunk and so does T. So I'm looking at those tables and I'm thinking which one has got something that's quite noticeably bigger than the rest. Or I might, for example, notice that table 2, all the frequencies are the same. So it looks to me like that must go with pie chart P, where all the sectors are the same. And it's a really interesting reasoning activity where you're developing students' understanding. If I look at a pie chart, what do I know straight away? What do I notice? And how does it relate to the underlying data? There's all sorts of lovely activities on Don Stewart's website for pie charts. This is just one of them where we look at a whole series of artwork and we say which pie chart relates to each picture. So for example, if I look at the top right picture and I see lots of blues and yellows, then I'm looking at a pie chart with lots of blues and yellows. And that's just a kind of nice enrichment activity, which just reinforces that idea of how the proportions in pie charts work and how looking at a pie chart just gives you a quick sense of the dominant colours or groups in the data. Don Stewart also has a load of really stretching activities on pie charts and tasks that have really got a high level of challenge, and pie charts can be made very challenging if required. So here we're perhaps using some algebra or perhaps some bar models or something like that to reason out the angles for each sector here. You can see that, I mean, I could show you a whole load of examples like this, but pie charts can have a really high level of challenge in it. Finally, I want to show you some resources from Miss Constantine. Her blog is absolutely fantastic and full of really good tasks, and that's Maths HKO is the name of her blog. And what she's done is created some really lovely activities. If you have a look at this one, it's a two-way table where you're trying to fit each pie chart into the right slot. So for example, less than a quarter of those asked chose chocolate, and we can see that there are a number of pie charts that fit in that category. So that's the second column on that two-way table. And then we say, well, how can we fit in and into each category in that two-way table the pie charts that we've been given there? It's a really nice reasoning activity. Finally, this one from the same author, Miss Constantine. This is exactly the sort of thing we should be doing if we want to develop proportional reasoning understanding with our students. So have a look at this. If yellow represents 7 on that first pie chart, then white must also be 7, yeah? So we know we have 14 in total because the yellow and white sectors are the same size. Whereas on the second pie chart, if red represents 9 people or 9 whatever, then white must be, 9 plus 9 plus 9, because it's 3 lots, it's 3 times the size of that. So then we can work out our total. And in the next one, if white represents 24, then we've got the same logic to work out green. It's 3 times the size of it. And on the next one, if blue represents 6, then pink must represent 3 and white must represent 3. So see how the proportional reasoning is fantastic. Like this, to me, is one of the best pie chart activities I've seen, because it's about making sense of the proportional relationships as opposed to just following a procedure and working out a load of angles, which is not what we're trying to achieve with this topic. With this topic, we want our students to become stronger in proportional reasoning and to understand that that's what pie charts are all about. Just to show you that there's a second part to that same activity. For example, if yellow on that first one represents 7, so we have 45 degrees representing 7, what's white? Well, it's double. And what's blue? Well, blue we'll have to work out, we'll have to reason as to what the rest of the angles are in equivalent. So it's a really, really lovely activity, and I really recommend using this one. This is, I think, my favourite pie chart activity. So that's it on pie charts. I hope you found that helpful. Do check out my blog resourceaholic.com, where I have resources listed for pie charts. The things that I mentioned in this talk are all linked through there. I hope you found that looking at pie charts in depth will change the way you teach it next time, or at least make you more confident that you have a thorough understanding of the topic. Do let me know how it goes.